Okay, hi Science 30. I'm going to do a quick lecture today just on the anatomy of the electric motor. Slides 25 and 26 in your electromagnetism PowerPoints is where I'm going to work from today, and then that's it. In your textbook, section 1.3 of Electromagnetism, page 349, is where motors and generators start, so you can read through that. You'll get some more info about the anatomy. I'm not going to do any equations today. I want to keep this a short lesson. Few things that you should understand. So electrical energy, first and foremost, is energy made by the movement of charge, so positive and negative ions. We're looking at the movement of electrons ultimately, but the movement of electrons can be influenced by other electrons moving or protons that are coming in and out of different membranes. They'll force electrons to move. What we're talking about with the production of electricity is ultimately to use the movement of electrons, which will be electricity, to do some type of work. So that's what mechanical energy is. So mechanical energy is the energy possessed by an observable object due to the motion or its position. It's the amount of kinetic and potential energy so that's what mechanical energy is. It's the total amount of potential and kinetic energy that an object possesses. Essentially, it's the amount of energy being made to do a job. All right. Right, so electricity is tough to measure because it's not directly observable. We can't necessarily see electrons as they move, but we can see the outcome of electron movement. So, when we hear sound coming out of a speaker, or we see, light being made from a flashlight or something like that, heat being made, or anything like that, electrons moving to perform a task. That's where we can indirectly measure the electric charge. So mechanical energy is kind of potential and kinetic energy with a point. So if you think about an airplane, for example, an airplane is not only possesses potential energy because it's been given energy to move away from the surface of the Earth against gravity. It's also flying at a relatively fast speed. So it has kinetic energy and potential energy. And the combination of those two are the mechanical energy, which provides the raw materials for it to fly. So the electric motor itself is a good place to look at energy conversions because we can measure mechanical energy with the amount of work in joules being done. Okay, so the electric motor, so there's definitions on this slide. So any electric motor has this basic anatomy, right? So you have electric motors in cars, for example, right? If a Tesla runs off of an electric motor, or a hybrid vehicle like a Prius, they all have electric motors, and they all use this basic principle. You have a magnet, and you have a spinning metal coil inside a magnet, right? So remember, magnets make magnetic force, and if you're going to move a metal inside a magnet, the electrons spin inside that magnet, and you can get an electric and magnetic field created, and that can be used to do work, right? So a spinning metal inside an electromagnet or magnet itself will create electricity. And so that's what that works. So when you think about your conventional car, right, you'll have magnets spinning on the axle, right? So, or you'll have the axle, or you'll have the metal axle spinning inside a magnet, and that can create electricity. And the coil inside, a car like a Tesla is a Tesla coil. It's a very efficient copper coiling, which possesses a lot of electrons that can create your electric force, which is then going to move your vehicle. All right, so that's what that is an electric motor. Okay, so a motor itself if I look at our definitions, so electric motor has the following main features. So it has an armature, so it has a spinning portion, and that spinning part will possess a wire coil. And on the armature there'll be a shaft or an axle which allows the spinning to happen, and then you're going to have a commutator as well, and that is where you can provide electrical contact. So electricity can either move in or out of the armature to either power the armature to spin or send electricity away to provide energy to do any type of work. So what's a commutator? So a commutator, like I just said, it provides electrical contact and it allows current to flow from the power source to the rotating coil or vice versa. The shaft of our armature is the support, right? So it supports the coil of the armature and it provides the axis of rotation to spin, right? So the axle in a car, for example, would be the shaft. If we're, moving any type of coiled metal through a magnet. You need a brush. Okay, so a brush is the stationary part of a motor or a generator. So that's the point of electrical contact. So the way the electrons move inside or out of the armature is through that brush. Okay, so if there's a power source coming in to move the coil and the armature, then electrons will be transferred from there. But likewise, that spinning coil can generate electricity as well. So the electricity will leave through that coil. Okay, so this is how electricity enters, and then obviously you need a magnet. Okay, so if we have a motor, right, if we have an electric motor, we have these pieces that are used to provide mechanical energy. So generally, movement of some sort to do work. A generator is really similar to a motor, but the purpose of a generator is to generate electricity in and of itself. It's not to convert that into mechanical energy directly, right? So in your textbook, right, not only do you have these explanations of motors and generators on in the electromagnetism unit, I'm going to actually point you to the last unit here. This is the energy unit, page 500. This diagram here, we're going to come back to this multiple times. But you can look at energy conversions in generators and motors. Right, so, if you think about a car, well, we have to have some sort of potential energy to burn. So in your typical combustion engine, right, you'll burn that energy. If it's an electrical vehicle, you'll be splitting water, right? A hydrogen fuel cell or something like that, or you'll be getting energy from like a lithium-ion battery. So you don't necessarily need to burn fossil fuels for that, but you got to convert that potential energy into kinetic energy. And then that's going to, right, the movement of the vehicle will spin the axle in a car, and then that will generate electricity as that spinning axle moves through a magnet. And this is how your basic zero emission vehicles work. It's the same principle as what happens in a generating station. Right, so in any generating station, we'll burn an energy supply, and this could be a fossil fuel-based energy supply, right? This is a coal-fired generating station, but you could have a hydro plant, right, where the purpose is to hold water back, and as the water, right, so what happens here is we will burn. Basically, every generating station does this. Every generating station uses a potential energy source, and that's used to boil water. And that water itself will vaporize. And then we move that vaporized water into a turbine, and as the water itself cools and condenses back into a liquid, the condensation actually moves the turbine itself. So that's really what generating stations do, is they use a potential energy source to heat water, and as the water changes state, that turns the turbine. And that turbine is connected to a large iron core with coils. And as that turbine rotates, the generator itself, right with the coil, so this turbine will spin a coil. Inside the generator, there's, right, that coil's inside the generator. There's a massive amount of electromagnets on the outskirts of that generator, and that coil rotates at a really, really fast pace in an electromagnet. So your power plant is just an upscaled version of an electric motor or an electric generator, right? And you could use nuclear energy for this, right? You can use geothermal energy. If we use hydro, right, we're not going to heat water. We're just going to, we build a dam, and then the water just rotates over the turbine itself, right? So, but they all use the same principle. Okay, so that's sort of fundamental concepts to be aware of. So that's your basic anatomy of an electric generator. Now, there's two things that you should be just sort of have a bit of an understanding of. Right, so we have the motor effect of motors and generators, and we have a generator effect. So the motor effect tells us that if we move a current through an electromagnet or a magnet, doesn't have to necessarily be an electromagnet, you create force. Right? So if we move an electric current through a magnet, that can create force to do work. So that's the motor effect. So we're moving electricity through a magnet in order to create movement. But the generator effect is similar. So again, remember that left-hand rule of electromagnetism, right? So your index finger is the direction of the force exerted. And so you have three things. So my middle finger is my electric field. My thumb is my magnetic field. And those two work together to create force. So those two fields working in perpendicular to each other actually create force in a linear direction. Okay, so that's the motor effect, is we can create force by having a current move through a magnet or be associated with a magnet. The generator effect does this. So the generator effect tells us that we can create electricity as a force is moved through a magnetic field. So vice versa, right? I can move a metal object through a magnet and create electricity. So I can use the electricity with a magnet to create force, or I can move some sort of force through a magnet to create electricity. So that's the generator effect. That's what generators do, right? They create electricity by moving a force through a magnet. That's what this shows here, right? So that spinning coil from the turbine moving through a magnet will create electricity, and then we can use that to power grids. Okay, anyway, that's all I'm going to talk about in this lecture today. It's not super long, but I'm gonna add more onto this, looking at slides 28 and 29. We'll look at current and different types of commutators and different types of generators another day. I just wanted to give you an introduction today. So we will chat later. Bye now.